Hello everyone and welcome to another YouTube video where today we will be covering what quality and quality improvement are. This is just a quick crash course video kind of introducing you to the two concepts, so buckle up and let's get right into it. In a previous video I covered the dimensions of quality, but let's get right into this video where we are going to start with the definitions of quality. So quality, there are two sort of definitions that are used in textbooks, and that is the means fitness for use, and that considered under design or even the conformance of the design. And also quality is considered inversely proportional to variability. So if you have minimal variability or variance, you're considering your quality to be very good compared to the inverse of that. Next, we also have quality improvement, and there is the reduction of variability in process and products, as well as the reduction of waste. Also, when you're thinking of quality, you always tend to keep in the back of your mind critical to quality characteristics. So these are things like physical, sensory, or time orientation, which you can categorize these characteristics under. For example, for physical, you can consider the length, weight, voltage, or viscosity as a critical to quality characteristics as physical. For sensory, there's taste, appearance, and color. And also for time orientation, there's reliability, durability, and serviceability. When considering quality, there's also a category that we will discuss, which are the means of measurement. So this is when you are making physical measurements of components that may need to meet a certain drawing requirement. So some terminology is nominal, upper specification limit, and lower specification limit. The nominal is a value of a measurement that corresponds to the desired value, while the upper specification limit is kind of like on the larger allowable value for a quality characteristic, and the lower being the opposite, where it's the smallest or minimum allowable value. So say, for example, you are machining a piston or the diameter of a rod, and you want that diameter to be 5 inches thick. You're not going to be able to always achieve 5 inches on every single part because there's some variability, and the price to achieve 5 inches exactly every time, it can add up and be quite substantial. So you end up having a tolerance. So if your tolerance is, say, 1 inch, which this is extreme because that would be quite a variety of diameters, but the upper specification limit would be that nominal 5 plus 1, making it a 6-inch diameter, or the lower specification limit being 5 minus 1, being 4 inches. So you would accept a diameter from 4 to 6 technically. And next are nonconformances. So nonconforming parts are failure to meet one or more specifications. Specific types of failure is called a nonconformity, and it's considered defects if it has one or more defects. Specifications are desired measurements for quality characteristics of a component or subassembly. So going back to the previous slide when I talked about the means of measurements, say we had a diameter of 4 to 6 inches, a nonconformance is considered deviating the drawing if, say, your diameter was for some reason 3.5 inches. That wouldn't be acceptable because that does not meet your design specification. So that concludes this quick little crash course into quality and quality improvement. These are two topics that you can spend hours on covering, but I hope this quick little introduction just kind of refreshed some memory or got you a little bit more interested into the topics where you can dive deeper into the two categories. If you did enjoy this video and found it useful, I'd really appreciate a like and subscribe to my YouTube channel, and I hope to see you guys in future videos.